Hi, my name is Ngan Vu, also known as NV. I'm a science product manager at Google DeepMind and a co-author of AlphaEvolve, a coding agent for scientific and algorithmic discovery, alongside my wonderful team here in the Computer Science Initiative. We went public just a few days ago on May 14, 2025. It's now May 19, 5 days later, and it's been incredible to see the attention it's received from news reports to many educational videos already popping up on YouTube. This enthusiasm inspired me to offer another way to understand our work through a presentation complementing the official white paper and blog post. Hence, here it is, Alpha Evolve 101. This is an introduction to Alpha Evolve through my personal lens. It's meant to be neutral, educational, and accessible, covering only public announcements but with some highlights on details that readers might be missing out on, as well as some anecdotes or analogies that I usually use to explain what Alpha Evolve is, what it is not, how is it similar or different to other concepts you might be familiar with. We'll also cover how to know if Alpha Evolve might be useful for your work, and if it is there anything that you can do about it right now? I hope this presentation will be an invitation for you to approach the white paper and the blog post, which will, of course, remain the definitive sources of truth. The work that we're discussing today is detailed in our recent white paper, representing the effort of a large team at Google DeepMind dedicated to advancing AI for algorithm discovery. The paper introduces AlphaEvolve, an evolutionary coding agent that substantially enhances capabilities of state of the art large language models. AlphaEvolve is already delivering real world values. It's been successfully applied to optimizing critical components of large scale computational stacks at Google, leading to tangible improvements in our data centers, hardware accelerators, and the very LLM underpinning AlphaEvolve itself. Importantly, these highlights are deployed applications with demonstrable impact, not prototype. AlphaEvolve is also pushing scientific boundaries, discovering novel, provably correct algorithms that surpass state of the art solutions. It found multiple new algorithms to multiply matrices, and notably, the first improvement after 56 years on a procedure to multiply two 4 by 4 complex value matrices, which can be applied recursively to multiply larger matrices. There are further results in the paper covering over 50 mathematical problems spanning many branches of mathematics. So, the key message here, this white paper, is AlphaEvolve's proven generality, one single framework that has successfully tackled a diverse array of challenges in both critical engineering applications and foundational scientific discovery. Recognizing that the white paper goes into a lot of technical depth, we also wanted to share AlphaEvolve's story more broadly. So, we've also published a blog post on the Google DeepMind website. This post is tailored for a more general audience, providing simplified look at our work and offering a way to register your interest for access to AlphaEvolve if and when it becomes available for your use case. We're very honored that Sundar highlighted AlphaEvolve and its significant contribution to Google computing ecosystem. Demis also shared our work and captured it very beautifully. Knowledge begets more knowledge, algorithms optimizing other algorithms. Interestingly, they both describe AlphaEvolve as an exciting flywheel of progress, one that's spinning fast. And speaking of that flywheel, if you stick with me until the end of the presentation, I'll share the story behind the graphic that Sundar shared and point out some details that might not be immediately obvious. With that, let's dive in. AlphaEvolve is an evolutionary coding agent to optimize and discover algorithms. That's a big statement, so let's unpack that a little. Algorithms are step by step instructions to solve a particular problem, like a recipe for making a cake. Algorithms themselves are just conceptual ideas. Computer programs, what you're seeing here, are how we concretely express and implement these ideas, these solutions to problems as code. So if we can evolve code, we can improve algorithm. That's what AlphaEvolve is doing here. is proposing changes to the existing piece of code, progressively producing better and better versions of this code. Its primary purpose is simply to optimize algorithms. And once in a while, this optimization pushed beyond the boundaries of the current human knowledge, and that's when it becomes a genuine discovery. What makes AlphaEvolve work so effectively? It really boils down to these three ingredients. First, the large language models, or LLMs. These are the creative powerhouses capable of generating diverse and novel code suggestions. Second is the automated evaluators. These are the objective judges that rigorously verify the LLM's code suggestions, effectively keeping them grounded. And lastly, an evolutionary framework. This is the conductor that drives iterative improvement. Here are those ingredients in a simplified animation. The creative LLM is largely responsible for code changes in a program. The rigorous evaluators are largely responsible for measuring programs against concrete metrics. And evolution is what drives the programs to perform better and better on those metrics, iteration after iterations. And as a quick aside, the illustration that you're seeing is actually a web app that you can interact with, developed by Gemini in canvas mode. It's truly amazing to see the sophisticated results achievable with Gemini's advanced coding capabilities. Now, knowing that, you might actually wonder, if Gemini is becoming so proficient at coding, do we still need AlphaEvolve? What more does AlphaEvolve bring to the table? The hint is in the problems that we choose to tackle, such as critical engineering applications within Google's already highly optimized large scale systems or foundational scientific discovery addressing long standing open problems. These are areas where a direct, one shot solution from an LLM is often insufficient right now. They demand a more systematic, autonomous, and robust search process. To address that, AlphaEvolve enhances the capabilities of the underlying LLMs like Gemini. AlphaEvolve isn't intended for everyday software engineering tasks. It's a specialized system that's most useful for tackling exceptionally hard problems. This focus is intentional. As we discussed previously, code is how algorithms are expressed on computers. However, not all pieces of code are critical algorithmic logic. Some of them provide scaffoldings and handle simpler operations, and some of them just need to be good enough solutions to be perfectly fitting for their purpose. AlphaEvolve is designed for that crucial smaller subset where good enough isn't the goal, but breakthroughs are. Now, let's start getting to the details of AlphaEvolve and how it's implemented, starting first with a bird's eye view. A simple way to think about this is that the human defines the what, the problem, and AlphaEvolve figures out the how, the solution. The human provides AlphaEvolve with a problem definition by setting evaluation criteria, providing an initial solution, and offering optional background knowledge. After its iterative process, AlphaEvolve then provides an improved solution. AlphaEvolve's implementation is an interplay of four key components working together in a cycle. The prompt sampler crafts prompt for the LLMs, providing rich context containing past trials and ideas from the program database. The LLM's ensemble uses these prompts to generate proposals of improved programs, which are then sent for evaluations. The evaluators pool automatically test these programs, assigns quality scores and other relevant feedback, and then passes them to the program database. The program database, which accumulates this information, selects promising programs to improve and act as inspiration in the prompt of the next round. Then the cycle continues, driving progressive improvement. Let's dive even deeper into how AlphaEvolve is implemented. First, who's the typical users? The humans who work with AlphaEvolve are usually scientists, engineers, or indeed anyone who likes to tinker and solve complex problems. To get started, the user provides several key inputs to define the task for AlphaEvolve. First, an initial programs with specific parts marked for AlphaEvolve to evolve and improve. This initial program can be very basic, even a single line of code, as long as it's functional. Second, evaluation code. This is a crucial piece that automatically assesses any new program's performance against metrics that we care about, whether that's achieving a mathematical objective or meeting SLO service level objectives in an engineering setting. Third, the choice of the LLMs in the ensembles. We use a combination of Gemini 2.0 Flash for generating many diverse ideas quickly, and Gemini 2.0 Pro for deeper, more insightful suggestions. And finally, prompt template and configurations for the prompt sampler. This helps automate how we provide context and instructions to the LLMs. These inputs set the stage for the controller loop, the evolutionary engine at the heart of AlphaEvolve. This loop is designed to be efficient, running in a distributed and asynchronous manner. Here's how that loop broadly unfolds. The loop begins by sampling a parent program, and at the beginning, this is just the initial program, as well as other promising inspirations from the program database. The prompt sampler uses the parent program and these inspirations to construct a rich contextual prompt for the LLM. The LLM ensemble then processes this prompt and generates a diff, essentially a set of proposed changes to the parent program's code. This diff is then applied to the parent program to create a new child program. The child program is executed and the evaluator measures its performance, producing results like scores and other feedback. And finally, this new child program, along with its evaluation results, is added back to the program database. This cycle repeats, driving the continuous search for better solution. And after a while, the best program, according to the predefined evaluation criteria, can be extracted from the program database. Now you know how AlphaEvolve works. With that foundational understanding of AlphaEvolve's mechanic, I want to shift our focus to six really important takeaways. These are often the aha moments that come up in my conversations or insights that the process flow alone might not fully capture. These key ideas will help explain AlphaEvolve's strengths, touch upon its limitation, and truly clarify its unique nature. Let's begin with what is arguably the most central element. Number one, code is a central feature of AlphaEvolve. The initial program with components to be evolved are expressed in code. This gives us a programmatic specification. The LLMs generate code diffs, so these potential improvements are inherently programmatic hypotheses. The evaluators are themselves pieces of code that execute the modified programs, meaning we have programmatic evaluation. To recap, AlphaEvolve is primarily based on code and results in algorithms. A helpful way to understand this code-centric nature is by putting AlphaEvolve side by side with AI Co-Scientists, another fascinating research initiative from Google. In the AI Co-Scientist framework, the scientist specifies a research goal in natural language. The system also proposed natural language hypotheses and evaluates these ideas using natural language processing agents. To recap, AI co-scientist is primarily based on natural language and results in hypotheses which might then be tested through physical lab experiments. It's very important to see these as complementary, not competitive approaches. It's wonderful that both these powerful methodologies are being explored at Google DeepMind. In fact, the AlphaEvolve paper suggests that AI co-scientists could potentially generate novel scientific hypotheses that then assist a human in defining the problem for AlphaEvolve to then tackle programmatically. Number two, AlphaEvolve is a test time compute agent, not a model. What does this mean? During the AlphaEvolve's discovery process, We're not training new AI models or modifying the ways of existing one. Instead, we leverage powerful pre existing language models like Gemini and query them many, many times within our evolutionary framework. This use of computation is usually called test time compute, also known as inference time compute. Another way to think about this is that the underlying Gemini models provide vast learned knowledge from their training. AlphaEvolve then supercharges these models by integrating them into its evolutionary search framework. This combination of deep learning and extensive search resonates with a key insight in AI research, often named the bitter lessons. It suggests that general methods that harness large amount of computation from learning and searching are often the most powerful and scalable in the long run. AlphaEvolve is an example of this principle in action. Number three, AlphaEvolve invests compute in highly complex problems. Because AlphaEvolve makes repeated calls to the LLMs and also to the automate evaluators, it can indeed be computationally intensive. So it's truly a heavy duty tool for heavy duty challenges. Given this, before considering a powerful system like AlphaEvolve, it's practical to ask, have you exhaustively explored simpler methods for solving your problems? Do you understand the limitations of these current methods and whether AlphaEvolve can address those limitations? Does the potential benefit of solving this problem outweigh the cost and setup involved in using an intensive system like AlphaEvolve? AlphaEvolve truly shines and provides the most value when these other avenues have been thoroughly considered and the complexity of the problem warrants such a sophisticated, search intensive approach to find those breakthrough solutions. Number four, AlphaEvolve is meant to assist humans, not replace us. It's designed to empower human ingenuity through AI collaboration. We find it genuinely fun to work with, and we hear that from our users too. This collaboration works on two fronts. On the solution side, AlphaEvolve delivers transparency. It generates its solution primarily as human readable code. It allows humans to understand the proposed solutions, gain valuable insights, build confidence, and then directly use or further modify these code based outcomes. On the problem definition side, human expertise is crucial in guiding AlphaEvolve effectively. Sometimes, especially with complex problems, initial specification might have unintended loopholes that an optimizing system like AlphaEvolve could inadvertently exploit. As illustrated here, the human AlphaEvolve interaction is therefore often iterative. This can involve redefining evaluation metrics to ensure that they truly capture the desired goal. It can also involve a human getting inspired by the strategy AlphaEvolve surfaces and decide to steer the exploration in certain direction more than other. This deep iterative interaction with humans is fundamental. That's why we're actively collaborating with the people and AI research team to continuously improve the user experience and interface, making this powerful human AI collaboration even more effective. Number five, AlphaEvolve can only answer how to the right what. The quality of the problem definition and evaluation criteria that humans provide directly dictates the utility of AlphaEvolve's results. Your ultimate goal is captured in the evaluation code. For AlphaEvolve to succeed, this evaluation should be 1. Fully automated during a run. Each solution must be evaluated automatically without human intervention during the loop. Humans can still change evaluation between each experiment. 2, it must be objective and quantifiable. It needs to be automatically assess solutions against clear scalar performance metrics. 3, reliable and goal aligned. The metrics must accurately reflect your true objectives to prevent optimizing for unintended loopholes. And 4, informative. The evaluation must provide a useful and consistent signal that reliably distinguishes better options to effectively guide AlphaEvolve's evolutionary search. Ultimately, if you provide an evaluation framework that truly captures your goal, then AlphaEvolve is well equipped to find powerful solutions. Another aspect to consider is time. 1. What is an acceptable time frame for you to receive a significantly improved algorithm or novel solution? For some scientific problems, the time frame could be as long as it takes for a breakthrough, but some of the other applications might have tighter constraints. 2. What is the reasonable time frame for you to get about 1,000 evaluations? To answer this question, you can think first, how long does it take for you to run one evaluation? And two, how many evaluations can you run continuously in parallel, considering licenses, compute resources, data, and simulator access and other constraints? The reasonable time frame for about 1,000 evaluation must be less than the acceptable time frame for significant improvements for AlphaEvolve to be useful for your use case. Number six, AlphaEvolve is LLM agnostic. This means that new or custom large language models can be swapped in or integrated into AlphaEvolve's LLM's ensemble. This opens up two possibilities. First is leveraging specialized model. If you have your own LLM specialized to a particular domain or perhaps fine-tuned on proprietary data, these can be added to the mix of LLMs. 2. Adaptability to future advancements. In ablations, we observe that AlphaEvolve performs increasingly better as the underlying LLM improves. Therefore, we're expecting AlphaEvolve to continue improving alongside the capabilities of large language models, especially as they become even better at coding. For example, Gemini 2.5, which came out a week before the publication of AlphaEvolve, offers better coding performance than Gemini 2.0, which AlphaEvolve currently utilizes. Now, hopefully, this presentation has helped you understand more about AlphaEvolve and whether it might be suitable for your work. We are actively exploring how we might provide access to AlphaEvolve for users outside of Google, including an early access program. For those interested, our blog post, which I mentioned earlier, currently contains a link to an interest form. This is a way for you to register your potential interest for if and when Alpha Evolve might become available for your specific use case. It's important to note that registering your interest does not guarantee access at this stage. We hope to expand access gradually over time in a responsible and scalable manner. This interest form is designed to be quite thorough, but it goes through the topics that we cover in this presentation. This is to give you the best opportunity to articulate your problems and its potential impact, as well as to help both you and us reflect on how Alpha Evolve's unique capabilities might align with your needs. We appreciate your interest and encourage you to check out the blog post for that form and for further details. In the meantime, while broader access to Alpha Evolve is being explored, a key way you can prepare for leveraging such AI system is by sharpening your problem definition, especially your evaluation criteria. As we highlighted, robust evaluation code is particular critical input for Alpha Evolve. This code is what programmatically defines your objectives and how success is measured. These automated evaluations are usually absent because rigorously defining them upfront can be challenging, but from my experience, the return on that investment is significant. This discipline of automated objective evaluation isn't just valuable for Alpha Evolve. Clear goals benefit any project regardless of whether you end up using Alpha Evolve or other tools. They provide crucial signals about solution quality throughout the process, whether an AI or a human is producing those solutions, and help ensure evaluation is integral, not just an afterthought. Now, last slide almost. For those who stuck with me to the end, here's the bonus that I promised: a closer look at the flywheel concept and the details hidden in plain sight in this graphic. First of all, this figure is not yet including a fourth application we introduced in the white paper and blog post, optimizing flash attention for inference at scale on GPUs. For the three applications that are illustrated here, optimizing data center, hardware, and software, they are impactful on their own. However, what makes them even more powerful is their interconnectedness, as hinted here by the magnifying glasses in the visual. The data center, illustrated here as a cluster of server racks, forms the essential infrastructure housing numerous tensor processing units, or TPUs. These TPUs are then the engines that execute critical software, such as the training processes of Gemini models. Gemini advances, in turn, allow AlphaEvolve to become better, enabling it to contribute back to this critical system. The deliberate use of the magnifying glasses aims to communicate that these are not isolated optimization. Instead, they represent interconnected levels of a cohesive stack. The impacts of these optimization are not merely additive, they are multiplicative, driving a virtuous cycle across our AI and computing infrastructure. That's the essence of the Alpha Evolve flywheel. Now you can point out to others about these details if you ever see this figure comes up, and I sure hope it does on a big stage. Thank you again for your interest in learning about Alpha Evolve and how it can be used for many scientific and engineering problems. Goodbye.